everyone, welcome back to our channel. So today in this video we are going to talk about class 10th physics chapter 1st, which is optics, reflection of light. Now this optics consists of two parts, reflection and refraction. So today we are going to cover reflection of light. Now firstly, if you hear the term optics, what does it mean? So optics actually means a branch of physics which deals with the study of light. So if we define this, we can write is that optics is nothing but the study of light. Now we are saying that optics is the study of light. Now we should know what is light. Now light is a form of energy which enables us to see all around for the sight of us. Now this is light. Now if we define light is the only object in this world, in this universe we can actually see, because apart from luminous objects, all are just reflecting light, and due to which images formed in our eyes. So light is very important for us. If we talk about few properties of light, we say light always travels in straight path. So it always follows a straight path to travel from one point to another. We also say light have two dual nature. It shows two nature. This we have two nature of light, dual nature of light, which is particulate nature. Particulate nature means it travels as if it is a particle. It is made up of a particle, and wave nature. Right? As if it is traveling as a wave. So particle we all know. Wave is something that travels, it is a disturbance that travels from one point, let's suppose from here to here, without the transfer of mass, just with the transfer of energy. So if we say in a wave which thing is running, then we say energy is propagating throughout the wave. That is what we say wave. And we know wave are of mainly two types, mechanical and non-mechanical. Non-mechanical waves are also known as electromagnetic waves, and that's where light is also a electromagnetic wave, or I say non-mechanical waves. So light is a electromagnetic wave. And you might have studied that electromagnetic waves are those waves which are always transverse in nature. We also studied in class 9 that transverse are those waves which have perpendicular directions, like particle movement is perpendicular to energy propagation. This is what a transverse nature is. So electromagnetic waves are transverse in nature. So these waves are transverse in nature. Now if we see the reason why electromagnetic waves are transverse in nature, so let's talk about that part. Let me rub this all. So as electromagnetic waves are transverse in nature means light is transverse in nature. So what is happening actually, that we have a particle. Let's suppose I'm having this particle A, and this particle A, the speciality is that this is a charged particle. This is a charged particle, and this particle in this case is stable. It's not having movement. So this stable particle A is having or developing electric field around this. So we have here electric field. So the stable charged particle is having electric field around this. Now, and if this charged particle A have movement, now what will happen? Then if this A is having movement, or it is propagating or oscillating, we say, we have oscillating charged particle. Oscillating charged particle. Now this oscillating charged particle, previously it is having the electric field. Now when it is moving, it will develop magnetic field also. Now we have electric field as well as magnetic field which is developing around this oscillating charged particle A, and due to this we say that this is having electromagnetic waves. Now this is how electromagnetic waves are produced, and electric field, magnetic field, and wave propagation or energy propagation all are perpendicular to each other, and due to this we say they are transverse in nature, because transverse is also where particle movement and energy propagation are perpendicular to each other. So this is the main reason behind the electromagnetic waves are transverse in nature. Then after, let's talk about the reflection of light, the main part of this chapter. Now firstly, if we hear the term reflection, what is the meaning of reflection? Reflection means whenever a thing is strike on a surface, it will bounce back with some angle, and this is what we call reflection. Light is also having similar case. Let's have a surface. This is a surface, a pretty smooth surface, and we are having a source over here. This is a person, okay? Now this person is emitting light, or you can say reflecting light, because it is a non-luminous object. So light is coming like this. Now if light is coming like this, it is striking the surface perpendicularly, it will bounce back. Now if it is like that, then it will have some angle. Now this line which is striking the surface and bouncing back, the line which is striking is what we call incident ray. Incident ray. And the one which is bounced back or reflected is what we call reflected ray. Reflected ray. And we have few laws. And for this, the line which is perpendicular to the surface is what we call normal. And the law of reflections hold good for all kinds of mirrors, whether it is a plane mirror, spherical mirrors. Spherical mirrors, as the name suggests, these are the mirrors which are derived from a sphere, are a part of sphere. Now, laws of reflection are the angle of incidence and angle of reflection are equal. Incident ray, normal, reflected ray are lying on the same plane. Now, these are the laws of reflection. Then after, let's talk about few more details about how images form, types of image, and all that. So before that, we have object. Now, what is an object if we define? So object is something which is reflecting light and we are seeing that thing. So that is the object. Now this object which is reflecting light is of many types, whether it is luminous, non-luminous, transparent, translucent, opaque. These are the objects. Now the first one is luminous. We all know, we have studied this in previous classes also. So the luminous is when object is having its own light, it is emitting out its own light, then we will say that the object is luminous. And the second one is non-luminous. Just opposite as the name suggests, if it is not emitting its own light, we will say non-luminous object. Now examples, luminous, in luminous we have sun, bulbs. These all are the luminous objects because they are emitting their own light, not reflecting light from any source. And if it is non-luminous, we will say like moon, planets, satellites, all the objects which you see like chair, and these all are non-luminous objects. We have transparent object. Now let's talk about these: transparent, translucent, and opaque. So let's suppose this is a transparent medium or a transparent object. This is a tube-like structure. So whenever a ray of light comes from a source, then this ray of light, if this is a transparent, so I am saying this is transparent, then all the light which is coming and striking the surface will definitely go back, means it is transferred to the other part or transmitted. Now this is the transparent object, and due to this, the objects which are behind this transparent medium we can see here, right? That is transparent. We have translucent, we have partiality, in that case, we have partial rays of light which are basically transmitted, and there will be image formation is like diminished or not bright. We have opaque where, let's suppose this is an opaque medium. So we have a source and the ray of light is coming. Then all the light, whether it will be absorbed or it will be reflected, it will be not transmitted to other part, and the objects which are behind this we cannot see. Like this board is opaque object. Right? Now let's move further. After this object, we have few terminologies. Before that, we have image. Now, what is an image? Image is basically the point when, let's suppose this is a mirror. Let's understand image. So we have a mirror, we have a source, and the ray of light is coming like this, reflecting like this. We should denote this like that. Okay, we have normal. Then image is when that this source of light when incidented a ray of light and this will be reflected, then the point at which two rays of light or more than that are meeting, and that point we see an image is formed. Okay, so we have, let's suppose it is coming like this and meeting like this. So in this case, this is a hypothetical situation. So in this is what we get as image. Now, images are of two types. It is real and virtual. In this example, it is a real image, and real image is always inverted, means upside down. Now, image, whether it is real or virtual. Real image is when the rays of light after reflection are actually meeting and we can obtain this on the screen. This is what we call a real image. And if we have virtual image, then the rays of light are not actually meeting but they appear to meet, and that point we say it is a virtual image. And virtual image is always erect and mostly enlarged. So virtual image is erect, means it's always straight. Let's talk about the reflection from plane mirror. So now we have different kinds of mirror. As I told you, plane mirror is something which is having the surface plane. So we have this plane mirror. How reflection is taking place is very easy. Just we have to understand few terminology. So we have a person over here, any object, incident ray comes, reflected ray comes, and at some point images get formed. At this point images get formed. This is your object. Now we have to understand the distance between the object and the mirror is what we say u. U, and the object and the distance between the image and the mirror is what we say v. This is the case of the spherical mirrors where we use mirror formula to solve numericals, right? Now what happens in the case of plane mirror is that this image is basically get formed in the back side. So at some point these rays of light are meeting and image is formed. This image will be of this equal distance as object distance and image distance are equal, and if let's suppose there is a person who is moving, this person is moving, then the image will be also moving in this direction if the person is moving in that direction. Let's suppose this is a mirror and I am moving like this, then my image will be also moving towards this, and the distance between me and this mirror is, and the image and mirror are equal, right? And this is what happens in the case of a plane mirror. And the image is basically virtual and erect, right? Of the same size. This is what the reflection from the plane mirror. So this is the reflection from plane mirror. In next class, we will going to talk about reflection from spherical mirrors. So till that, continue watching this video. And this is all about this today. So thank you for watching.